And we're back. All right, if you are joining me from the last video, we have looked at some of the network signatures for this new unknown binary. If you didn't watch that one, go ahead and make sure you watch that one first because this is part 2 in this little series for doing the basic dynamic analysis on this sample. So go ahead and watch that one. But if you have already watched that one, keep on rolling with this one. So now begins the game of guessing what this binary could be doing, given that we have a couple of key facts. So we know that it's made an HTTP request out to a specified server. We know that it has downloaded something that has been served up by inetsim, but in real life could be some kind of second stage payload. But now we don't quite know anything else at this point, but we can start to use these as base facts to start to unravel the rest of the capabilities. But before we do any of that, we have detonated our binary and we should revert back to a clean state. So we'll go ahead and do that and I will cut to when the revert has succeeded. All right, we're back and I have reverted and we'll arm our binary and set it back so that it can be executed. So let's take a look at our notes and we have a potential file download. We know that inetsim needs to be running or else we'll get this error block. And so let's take another look at some of these strings and see what we can determine. So if we have a potential network indicator, maybe we can start to chase down other host indicators given what we know about how it interacts with the network. And so while MSD core lib may not be the name of the binary as it's written to disk, we also happen to have a file path here. And so it looks like app data roaming Microsoft Windows start menu program startup. So the startup directory. So commonly used to put in programs to start when someone logs in, and a very common vector for malware to abuse. Now, could it be that msd corelib.exe is written to the startup directory? That is a hypothesis that we can put together, and maybe we can test that. Now, one way that we could do that is using procmon. What we can do is go run procmon and agree to the license agreement. Now, we do have the name of our executable, so let's go ahead and copy that, and we'll go to the filters, this little filter icon right here, and we'll set this to the process name. There it is, I was looking for it, but is, and then we can put in our rat_unknown.exe, and we hit add, and we hit OK. Now, there won't be anything here yet, but that's okay. We haven't detonated yet. And make sure we can double check by going over to our Remnux box. We can go ahead and stop Wireshark. We can make sure that inetsim is still up and running and it looks good. So remember, we're after host-based indicators, so we don't need to necessarily worry about Wireshark output. We've already captured that. Let's go ahead and double click and run. And immediately we've got tons of information here. I mean, there is just so much going on here to look for. But remember that we meet the criteria for detonation, so we should not get that pop-up box, right? We have it connected to a fake internet resource that it's drawing from. Now we can start to look at the host-based indicators, and one of the most useful columns of data that we can filter on here is operation. Operation has things like process start, registry key values that are opening, closing, being read, file creation. So it also has some information about TCP sockets that are opened up during the detonation of the malware. So it can be very interesting to go ahead and filter on the operations here. So if you ever wanted to know maybe the different file operations that are going on, you can go operation contains, and then we can do something like file, add this as criteria. And now we have in the operations column things like create file, query basic information file, and it looks like this binary is querying information out of tons of different DLLs. And that makes sense, right? Lots of different capabilities that a binary might rely on are in different DLLs. And this is still going to be a lot of information, but we can start to cut down on the different things that we're looking for by giving different filter criteria. Now, if you recall, there was one string in this binary that could be very telling about what this binary may be doing from a host-based indicator perspective. Now let's go back to our notes and let's scroll back up to the strings that we have. So remember, this file path right here, the startup directory inside of app data, is commonly abused and used by malware to either install itself as persistent or perform something at startup, maybe install a second stage payload, have it run when someone logs in. So this is a very, very juicy indicator that we want to latch onto. So from our notes, we're going to take our app data, roaming, et cetera, et cetera. And one of the other very interesting and useful filter criteria here is the path filter. And we can add path, contains, and then we can put in our file path here and click add. And so we can actually filter off the operation contains file because we have another criteria that we're testing here, and hit OK. Again, if we run this, we can see if something happens inside of that file path, and it absolutely does. Now let's take a look at these indicators, because this could be one of the key critical pieces of functionality inside of this malware. We may have just discovered the persistence mechanism of this piece of malware. So let's take a look and analyze. So we have CE users Husky, app data roaming, Microsoft Windows, et cetera, et cetera, et cetera. It goes all the way down to startup. And that mirrors pretty accurately the string that we pulled out of the binary. App data, roaming, Microsoft Windows, etc., all the way down to startup. Now it looks like it concats right at the app data right here. So in other words, looks like it doesn't need to know the first part of this full file path. It looks like it can dynamically guess, okay, the user right now is Husky, and this will be whatever your user is on your box. And then it'll say, okay, in the app data directory, drill all the way down to startup for the Husky user. And we can tell that because there is no C users Husky in the strings here. It looks like it determines that dynamically. All right, moving on, let's see what it actually does. We can expand this details pane right here, and there's going to be a lot of information here. So let's go ahead and maximize this screen and expand this all the way out, and we can even just hover over it to get like a tooltip here. So we're looking at the mscore.dll.exe, right? And so it looks like it's using this as the name of the file that it is trying to write to. It looks like it's giving write access to this location. And it looks like our operation is create file. So if you recall, we did not make a GET request to the server for mscore.dll.exe. Our GET request was actually a little bit different, msdcore.lib.exe. But it looks like it may be writing this file to the file system under the name of mscore.dll.exe, which is weird for a couple reasons, right? First of all, why are you calling something that has a DLL in the name and exe? This is an executable, and this you would ostensibly think that this is a DLL, a dynamic linked library. So that doesn't really make a lot of sense. Also, the fact that this is being written into the startup directory in app data is also pretty suspicious. So we're going to go ahead and take screenshots of this. So go ahead and grab these screenshots. This is all very, very juicy information that we want to hold on to. So we're going to say host based indicators and throw that in right here. And we've got all kinds of information now to look at here. That mscore.dll.exe looks like it's pretty suspicious. And hey, why stop there? Why don't we actually open up that startup directory and see if it actually wrote something? Because it says that it succeeded, but you never quite know until you check. So let's go ahead and grab this. We'll copy, and we'll just go to any file explorer window and go to the startup directory, and sure enough, we've got mscore.dll.exe. If we double click on this, remember that this is the inetsim default GUI binary. It does not perform any malicious functionality, but it does represent that something was downloaded from the internet and written to the file system. And it's now in the startup directory, meaning that if you log out and log back in, whatever is sitting right here is going to be executed at the time of login. So that is a pretty tried and true persistence mechanism for a piece of malware, and that is also something that we want to put in our notes. Let's go ahead and take a screenshot of that. Make sure you get the full file path in here. We'll copy that to the clipboard, and we'll say persistence binary, and we will paste in that screenshot. Excellent information so far. So we've got a web request out to a specified server. We have a web request download of an executable. That executable is named something different from what it was downloaded as and written into the startup directory. And all of this is contingent on there being a working internet connection to get to some kind of web resource. Otherwise, we get an error message, no soup for you. But we're not going to stop there because there's more to this binary. And so we're going to do another round of analysis. But before we do that, we should, and you know what I'm about to say, reset your VM, send it right back to the restore current snapshot to whatever your pre-detonation snapshot was, and hit OK, and I'll meet you back there. All right, so we are back out. We have rearmed our binary and reverted back to a clean snapshot. And for the next set of indicators that we'll get out of this binary, I want you to think a little bit about when a host needs to make a connection to some other host, how does it think about and know what that connection is, right? And so the host itself needs to understand the concept of TCP if it's going to make a TCP connection. So there are classes of functions that the operating system needs to understand to be able to perform that TCP connection. Now, from the host-based perspective, we can actually pick up on some of these indicators as TCP artifacts, meaning that maybe a socket opens, maybe a connection goes out, and all of this is coming from the host itself. So when we talk about network indicators and host-based indicators, there really is a certain subset of the host-based indicators that have to do with network signatures, but they're not quite out live on the wire. We can't really pick them up with Wireshark. They're happening on the host, and that's where we should look for them. So one of those is going to be an open socket for TCP connections on the host. And we're going to use a tool to see this called TCP View. Now, I have installed the sysinternal suite in my program files directory, and this was a function of the fact that during the Flare installation for this course, it did not install the sysinternal suite correctly, so I installed it myself. And if you do not have the sysinternal suite on your workstation, you can grab it right off the Microsoft website. It's free, and it's a very quick download, and I've included the instructions for that in another video in this course. I'll link it in the resources, so go check that out. Now, in any case, let's take a look at what TCP View can do. So when we open up TCP View, we have the window of all of the different types of connections, the state that they're in, a local address, remote address, and port itself. And this is very important because you can tie this all to a module name and a process name. So let's sort by alphabetical order here. So we'll click that a couple times. And to make it very easy for us, we'll just take note of our process name, which is rat unknown, and we can go ahead and find that. When we double click here, we should be able to scroll down, and it actually helps out by highlighting in green when there's a new connection established. But we actually do end up seeing the process name of ratunknown.exe has a couple of TCP protocol events associated with it. So let's analyze. We've got ratunknown.exe is now in a listening state on all addresses. That 0.0.0.0 just means don't pick a specific IP address, just give me any IP address. So it's listening on all addresses at local port 5555. This is a fantastic indicator, so let's go ahead and screen cap it. And we'll say TCP socket in listening state, and there we go. All right, so we have a socket open in a listening state on port 5555. Now, we can go over to something that's in the network, like our Remnux box, and we'll go ahead and go to a new tab. And we've got this wonderful little tool called Netcat, which you can invoke with NC. And Netcat can act as the kind of Swiss Army knife, they call it, of networking TCP and UDP connections. And so now that we have an open socket, we have another tool that we can use to interact with this socket. And so we will invoke netcat with -nv for no DNS resolution and verbose mode. And we will type in the IP address of our remote host in this case, which is our Flare VM box, and the port that is now specified, which has opened up on 5555. And it looks like when we make a successful connection, we are greeted with what is certainly base64 encoded information. Now, Remnux has a base64 utility that's built into the operating system. So what we can do is we can take any string of interest that we'd like to decode, copy this, we can echo this right into the terminal and just paste it in between the two sets of quotation marks, and we will pipe this to base64-D. And when we hit enter on that, we are greeted with the base64 decoded text, which is what command can I run for you. All right, so we've got a couple more indicators here. Let's go ahead and take another screenshot of this. So we'll go ahead and grab everything on the screen here. We'll copy that to our notes by saying base64 encoded data from socket on TCP 5555. And we'll throw that screenshot right in there. What command can I run for you? So that's pretty interesting, right? So let's start to look at the inputs of this open socket now. So you can send information like ipconfig, and it looks like we've got something in return here. So let's say that this is the encoded information. So let's take a look at what the decoded information. So let's paste this into there. And when we base64 decode, it looks like, yes, indeed, we have command injection capability from this that is returned in base64 encoded format. So again, very good to take a screenshot of this because this has confirmed what the initial report said, which was that this is likely a command injection or command execution capable remote access Trojan. We'll say something like command injection capability, and we will paste in our screenshot there that proves it. And of course, we can always kind of resize these if we need to. We can go ahead and open it up so that it's just a little bit easier to read. But we have a pretty good indication that this is a remote access Trojan. It's able to inject with commands and return information by injecting and executing on the file system. And we can prove this by maybe doing a few more. We can do ID, and we'll go ahead and remove everything from the line. And there we go. We have the output of the ID command, which looks like it does indeed run. And then maybe something else I'd like to do is just kind of throw in some random text here to see if it handles certain exceptions. And we can take the exception here and let's take a look. Let's delete out our other base64 text. And the system cannot find the file specified additional info requested command not found, ASD, ASD, ASD. So it does in fact handle those exceptions. So this looks like a full-blown command execution remote access Trojan. It opens up on port 5555 to the file system. It has command injection capability, and it also looks like it writes something. Maybe not it writes itself to the startup directory, but it does look like it writes something to the startup directory. So at this point, we've got plenty of information to go off of to say that this is a piece of malware. We've got network signatures, we've got host-based signatures, and at this point, we can call this whatever we want. So we'll go ahead and call it rat cmd socket.exe.mals. Now back over on our Flare VM box, we do have TCP view up and running here, but why don't we combine this with another tool to see if we can start to cross-correlate? And so we will open up Procmon one more time, and we'll go to our filter criteria, and let's filter for the things that we know at this point. We know our process name is going to be rat_unknown.exe. So we will say contains, or it could be is for that matter. We'll open that up. And then we'll also filter for the operation contains TCP. And this kind of does something similar to what TCP view over here is doing, but we can get additional information out of this as well. So let's go back over to our Remnux box. And remember, we have the open command socket here. So let's do the ID command. We do get a callback from that, but let's look at what happens over here. And we open up the details section here, and it looks like we do have a successful TCP receive and a TCP send coming off of process name of rat.unknown.exe. So in lieu of something like TCP view, we can use Procmon to look at the TCP operations, which could include send receive. Maybe the socket opens up. Let's go ahead and go to task manager, and we'll find the rat unknown, which should be right around here. We'll end this task, end process, and then if we keep this, we can see the TCP disconnect. That's another indicator that we have in the TCP operations section. And if we double click on this and run this rat one more time, we have all kinds of information. We've got TCP connect, send, receive. And so this goes to show you that Procmon can also be used to filter on these operations. Super powerful, super important to look at the different types of things that the process is doing on the file system and the operating system. And now let's take one more pass here. Let's open up our criteria to be a little more broad. So let's uncheck the operation contains TCP. And here from the blank process monitor screen, we can go ahead and just click the clear button if you have extra information that you don't want. Remember, we're going to start fresh here. So let's go back over to Remnux. Let's issue another command. Let's do who am I? And we do get the base64 encoded response here. But what's more important is to look over here on the host for this. And it looks like we have a lot of information here, but it does in fact try to find the whoami.exe binary. And so that's interesting as well. With this command injection, you can actually see the mechanisms for how the command injection takes place. And it looks like it's a straight system execution. It looks for maybe a binary that's called that, whoami.exe. And in this case, it found it inside of system32. And it performs whatever that binary is meant to do, and it returns the information by TCP sending it back to the origin for the client that's connected to this command injection server. So let's wrap this up. At the end of the day, what does this really look like when it comes to malware? Well, we can call this a couple things. This looks like a remote access Trojan. It looks like it has command injection capability. But remember that it opened up a listening socket on the host that it infected. And there's a very specific term for this. This is actually a bind shell that looks like it has command injection capability. So we have bound port 5555 to the operating system, and we say anybody who connects here on port 5555 can issue a command. And remember, if we open up Remnux over here, we can issue a command after we have connected to this port successfully, and the command will be executed on the operating system, given that we took a look at our process monitor and we found that it will look for something like who am I, or maybe it opens up cmd.exe and executes it that way. It reads from the output of that execution and it sends it right back to the client that has connected. Classic bind shell, meaning that we have to connect to it first. We're able to issue commands to it, and the command output is returned to us. So we can call this rat unknown. We can call this rat bind shell. I think you can really call it whatever you want, but I'm going to go ahead and call this rat command shell.exe. And with our report, we can now submit that for additional analysis, given that we have performed the triage and the basic dynamic analysis successfully. So great job there. We have looked at a piece of malware that's able to inject, execute, and return the output of commands on the operating system. Good stuff.